Okay, basic differentiation rules, day 2. Okay, so we learned the basic rules 2 days ago. Then we looked at differentiation and continuity yesterday. Do we know what page is going on? 34. Okay. So we are going back. Well, we're not going back. We're going to apply the things that we've learned the last couple days here. So let's think about what we need to do. So this just says determine the points. So that implies there could be more than one, right? Which the given function, here's our given function, has a horizontal tangent line. Okay. So let's think about this. What do we have to get information about the tangent line? The derivative. So this is f. The tangent line, which is what we need information of, we're going to need f prime, right? And I need it to be a horizontal tangent line. What is the slope of a horizontal line? It's a y equals line. So what's the slope? 0. So the slope is 0. And doesn't the derivative give us the slope of the tangent line? And we want our tangent line to have a slope of 0. So we need f prime of x to equal 0. Does all that make sense? So here's the thing, is that you've got to make sure that when you see certain words, it makes you think certain things, right? Tangent lines is slope, and it's the derivative. It's what we need. So we're going to find the derivative of f of x. So f prime of x is going to be equal to 3x squared. And what's the derivative of negative 12x? Negative 12. Okay, minus 12. So there's the derivative. That is the equation for the slope of a tangent line at any given point. So we don't have a point this time, so we're not substituting in something for x like we had been, right? Instead, since this gives me some slope, I need to know what x value is going to give me the slope of 0. So f prime of x is going to be 0. It's equal to 3x squared minus 12. Okay. So then I can factor that. Let me get 3 times x squared minus 4. Can I factor this? What is that called? Difference of squares. X plus 2, x minus 2. So solving that, I get that x equals plus or minus 2. Okay. So now again, it's not all about getting the numbers, because we've got to think about what we just found. We found the x values for where on our function here, which is a cubic function, it's our x values for when our tangent lines will be horizontal. Okay? And it says determine the points at which the given function has a horizontal tangent line. So I now need to take this, I found it from f prime, but I need to substitute it into f. So I'm going to find f of 2. So that's going to give me 2 cubed minus 12 times 2. So that's 8 minus 24, negative 16. Okay. And then f of negative 2, which is going to be negative 2 cubed minus 12 times negative 2. So that's negative 8 plus 24. And that gives me a positive 16. Everybody understand where I got everything from? Why I chose to substitute it in the things I did? Okay. So what I'm looking for are the points at which the given function has a horizontal tangent line. So I can say f has a horizontal tangent at, okay, and these are points, so they're ordered pairs, they're not at x values. So I have 2 of them. I have the positive 2, and my positive 2 gave me a negative 16, because that's my y value, right? Negative 16, and at negative 2, positive 16. So yes. When you put the u, those are with intervals, when you're unioning intervals. Everybody okay with all that? We good? Okay. Any questions? So you notice how we took the fact that we knew how to find derivatives and what they give us, and we have to be able to meld that into whatever the heck they're asking for. Yes, exactly. And that could be it. Okay, that's a good question. Anything else? Okay. So this is the same kind of question. It says determine the point or points at which the given function has a horizontal tangent line. So again, the tangent tells you need f prime. Horizontal line tells you that the slope is equal to 0, and that is the slope, right? So we're going to take the derivative. F prime of x is equal to, okay, what's the derivative of x? 1 plus, what's the derivative of 2 sine x? Cosine x, and then I put the 2 on there, so yes, 2 cosine x. Okay. Everybody good with me so far? All right, so now I need the slope, which is the derivative here, to be 0. So 0 equals 1 plus 2 cosine x. So I subtract 1 from both sides. That's equal to negative 1 equals 2. What? Because the derivative of sine is cosine. Yeah. It's like a little chart. And I started Googling, like, there's got to be, like, some mnemonic or some way to, like, remember that, you know, to memorize that if you don't know them. And I didn't get very far, but I'm going to find some. If not, we'll come up with our own, like we did FEPL. Okay? Fine. Whatever works, right? And that's what you're going to have to learn to do, especially in college. You're going to make yourself, that's how the tangent ones, what is it? Oh, God, I can't remember. Never mind. You are one overwhelming third wheel, right? Yeah, that one for tangent. You are one overwhelming third wheel. And so the person that told me about it, I contacted that teacher. I was like, hey, I've never heard this before, so I'm stealing it. Because like everybody's heard of SOHCAHTOA and stuff like that. And he was like, yeah, I had to figure out some way to remember that when I was in college, and I made that up myself. And I was like, well, I'm using it. And I'm going to give you credit for it. I have no idea what his name is, but he taught at Pearland High School. That's all I know. I am, and I will give you all credit. Okay, 1/2 cosine x. All right, so I need to know, and it gives me this interval between 0 and 2 pi. So there could be more than one answer. Let's think about that. This is negative. What quadrants is cosine negative in? 2 and 3, okay? So I need 2 and 3. Those are the quadrants I'm getting it from. So let's just go with 1/2. The cosine inverse of 1/2 is what? No, it's going to be an angle. This would give me the 1/2. What angle is this?
60.
This is 60. No, this is 60. I'm sorry. This is 30. This is 60. But what is 60 in radians? Pi thirds. Okay, so it's the pi thirds angle, right? But I don't want, it's a pi thirds angle, but I don't get to use the first quadrant because it's negative. So what's my second quadrant pi thirds angle? 2 pi thirds. Ugh, what is wrong with me? And 4 pi thirds. Okay? So those are my 2x values. Make sense? Unit circles. You got to know it still. I wasn't lying, I promise. Okay, so now that I have that, those are the x values at which I have a horizontal tangent line. So I now need to find what the y values would be, right? So I'm going to substitute it now back into f. So I'm going to have to find f of 2 pi thirds. So that's going back in up here. So this is going to give me 2 pi thirds plus 2 times the sine of 2 pi thirds. Right? So what is the sine of 2 pi thirds? What's the sine of pi thirds? Let's do that. What's the sine of pi thirds? Blip, 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 blip. Okay, if the sine of 2 pi thirds is going to give me not a pi answer, right? This is the angle. My output's going to be like 1/2 square root of 3 over 2 square root of 3.
Oh.
So if this, Square root of 3 over 2. Oh, there we go. Yes. So this is my pi thirds, right? Square root of 3 over 2. And then 2 pi thirds. Is sign positive in the second quadrant? Yes. Okay. So I'm going to have 2 pi thirds, or I'm going to have square root of 3 over 2. So let me just write this down. We've got 2 pi thirds plus 2 times square root of 3 over 2. We agree with that? Everybody with me so far where we got everything? Okay. So that means that this is going to equal then 2 pi thirds plus what? Square root of 3, because it was canceling. Okay. Which looks weird, but that's fine. Well, that is the y value when I have this x value. So it's one of my answers. So there's nothing, no, we can't I mean, you could make it into one fraction, but you don't need to, so let's not do it. Okay. So then we're going to do 4 pi thirds. So f of 4 pi thirds is equal to 4 pi thirds plus 2 times the sine of 4 pi thirds. So what's the only difference between the sine of 2 pi thirds and the sine of 4 pi thirds? It's negative. And so that means that this is going to just give me 4 pi thirds minus square root of 3, right? Because the same thing's going to happen with the 2's. And that's the y value for this x value. So my answer then is I can say f has horizontal tangents. Oh, if I could spell. Horizontal tangents at weird looking ordered pairs, I'll give you that. My x value is 2 pi thirds. That x value gave me this y value, 2 pi thirds plus the square root of 3. And when x is 4 pi thirds, we have 4 pi thirds minus the square root of 3. What questions you got? You got to keep track of, am I supposed to be using f right now or the derivative? So f or f prime. And that's why it's not a bad idea to kind of label what you have. When you want the point from the graph, you put it into f. Okay, we all good so far? What questions you got? All right, let's try one that's a little bit different. So it says to find k, so some constant k, so that this function will be tangent to the line, this right here, okay? So k, so that the function will be tangent to that line. So let's just think about what that looks like as far as a graph is concerned. Okay, so let's just say that I have, k is just a number, yes. So I have to figure out what that number is. K is just some constant, it could be 5, it could be just some kind of number. So this is some sort of quadratic. So let's just say that our quadratic looks like this. And let's say that this line looks like this, okay? Don't quote me on that. I know that's not an exact graph. But if it's tangent, then they have a common point, right? Does that make sense to you? So I need to know when they have that common point. So since I'm looking for that, I'm going to take these two and I'm going to say that they have the same y value. So this is equal to y and this is equal to y. So I'm going to do substitution and set these two pieces right here equal to each other. So x squared plus kx has to equal 2x minus 9. Okay, everybody okay with that? So we are talking about a tangent line. Where do we get our tangent information from? F prime, okay? And if this, what information is this right here? It's the slope of what? Of what line? Will be tangent to the line. It is a tangent line. Okay, it's okay. But so this line is tangent to the function, and the function is tangent to the line. I think that's the first time it's been written that way, that the function's tangent to the line. They're tangent to each other. So we usually talk about the line being tangent to the function. But that makes, if it's tangent to this line, that makes this a tangent line, right? So that makes this the slope of the tangent line. Slope of tangent line. Yes. So that means I want f prime of x to equal 2. Right? You see how you got all those pieces from that? Okay. Now, do I have f prime? No. But I'm going to need to do something because I have two variables here. And I don't have enough information to just find k right now. So I'm going to find the derivative. So the derivative of x, f prime, is going to be 2x plus what? Plus k. Because if this was 5x, what would the derivative be? 5. And k is just a number, so it's just plus k. All right, everybody with me so far? Now, what did I say I want f prime to equal? 2, because that is the slope of the tangent line, and this is the equation for the slope of the tangent line. So I can say that 2 is equal to 2x plus k. So what I need to be able to, I need k, right? So to get k, I'm going to subtract 2x from both sides. So I get 2 minus 2x, that's equal to k. So now I have two equations, and I have two variables. That is a system of equations. And I can take this and substitute it in for k right there. Yes, because x is still x. Because like we're still on the same graph. Does that make sense? Okay, good question though. All right, so we've got that. So now let's substitute this in. This is going in, boop, right here. So we'll do x squared plus, now my k is 2 minus 2x, and then times x, right, equals 2x minus 9. So this right here is my k. Everybody with me? Okay, so now I'm just going to clean this up. So I get x squared plus, so I'm going to distribute my x. So it's going to give me 2x minus 2x squared equals 2x minus 9. Okay. So I have my x squared and my negative 2x squared. That's just going to give me negative x squared, right? What happens when I subtract 2x from both sides? Yeah, can't they zero out, right? And then that equals negative 9. Which means x squared equals 9. What does x equal? Close. Plus or minus 3. Plus or minus 3. Plus or minus 3. All right. Are we done? What are we looking for? K. Right? It says find k. We didn't find k, but we found some x's. Now that I have x values, can I find k values? Yes, because I have this k right there. What do y'all do? Put your phone away. All right, so I have two x values to substitute in here. So now I can say all of this stuff is true, therefore k is equal to 2 minus 2 times 3, which is negative 4, and k is equal to 2 minus 2 times a negative 3, which is 8. What questions do you have? Are we all good? Okay, so it's kind of the same work, but you have to know when to use what and make sure you're using f when you need to use f and f prime when you need to use f prime, okay? We all good? Ask me a question. Okay. No. Mm-hmm. Because I'm finding the derivative of this. So I do 2 times x, so that's where I get the 2x from. And then like if this was 5x, it would be 5. Okay, this is derivative. Oh, no, this wasn't coming from here. It was coming from here. Good question. Stop it. All right, we good? That came from right here. So after I found the derivative, I solved for k, right? And then I took this and I substituted it right in here and then went over here. Okay? Are we good? Okay, good question. What else? Okay. All right, so now we're going to find a and b so that f is differentiable everywhere. When you see differentiable, what do you know for sure is also true? Continuous. And we want to find, we need to try continuity first, right? In order for it to be differentiable, you want to check continuity first. So we got to check 2 things. So I'm going to check my continuity. In order to do that, the limit as x approaches 2 from the left. Okay, so if I approach 2 from the left, it's this equation, right? Limit of ax squared plus 1. That has to equal the limit as x approaches 2 from the right. And if I approach from the right, it's bx minus 3. Right? So in order for it to be continuous, those 2 things have to be true. Yes? Or that one thing has to be true. Plus, we have to be able to find the point. The point is going to exist, so we're fine with that. So I have this. So if these 2 limits, they're going to exist, then now I have to actually evaluate this. So I put 2 in here. This is going to give me 4a plus 1. And that has to equal, when I do direct substitution and 2 goes in here for x, 2b minus 3. Okay. So I have 2 variables, which means I need 2 equations. So I need something else, right? So I can look at my differentiability. In order for it to be differentiable, I have to find f prime, right? And so f prime of x is equal to, so I'm taking the derivative of this. This is going to be 2 times ax to the first. So I get 2ax. What's the derivative of 1? 0. And then this is just going to be x is less than 2. I don't know if I can put the equals on there yet. Then I have bx minus 3. So what's the derivative of bx? B. What's the derivative of minus 3? 0. And then this is when x is greater than 2. So in order for it to be differentiable, I have to say that the limit as x approaches 2 from the left, so if I approach from the left, I'm using 2ax, has to be equal to the limit as x approaches 2 from the right. If I'm going from the right, I'm using b. Everybody with me so far? Then I'm going to do direct substitution of these. So this limit, I'd substitute in 2 here, so this is going to mean that 4a equals b. Everybody with me so far? And then we're going to substitute, yes. So now I'm going to take this. I have 2 equations, and I have 2 variables. 4a equals b. So that means that 4a plus 1 equals 2 times 4a minus 3. So 4a plus 1 equals 8a minus 3. So I get 4 equals 4a. So a equals 1. We all good with that? Now I also need b. So I'm going to take this, I'm going to substitute it over here. So 4 times 1 equals b. So b equals 4. And then we should write a little sentence. There's not enough room here, but, you know, saying that these things are true, therefore they're differentiable. Okay, we good? Okay. Let's look at another one. We're going to find this derivative and write the equation of the tangent line. So find the derivative. If it's y, my derivative is going to be what? dy dx. Good. All right. And so then we're going to write the equation of the tangent line to the curve at this point. So if I'm writing the equation of a line, I have to have a point, and I have to have a slope. I get my point from f and my slope from f prime. If they didn't straight up give me the point, if I only got the x value, then I substituted into f, or this is y, but you know what I mean by that, right? So I have my point. It's at 1, 7. It told me to find the derivative, but it really didn't have to. It could have just said, write the equation of the tangent line, then you have to know that it's the derivative. But either way, what's the derivative of 3x squared? 6x. What's the derivative of 5x? 5. What's the derivative of negative 1? 0. Okay, so here's this. So in order to find my slope, I'm going to use dy dx evaluated at x equals 1. I use the x value from the point that I'm using, and that's how you do it instead of saying like f prime of x equals. So then this equals, when I evaluated at 1, I'm going to get 6 times 1 plus 5, which is 11. And then is it fairly simple to write the equation from there? Yes. I get y minus what? 7 equals 11 times x minus 1. And there we go. Okay. What questions you got? Okay. All right, so let's do one more of these, and then when I give you the assignment, we're going to do the first one on the assignment, because I think it's strange that it's even on that assignment, but it's fine. What might this look like on an AP exam? So we have this function where b is a constant. Okay, we used k on the other ones, this one's b, whatever. If the line tangent to the graph of f at x equals 2 is parallel, I don't know why it's split like that, to the line that contains these points, what's the value of b? Okay, so if I have a line that's parallel to another line, what do you know has to be true about them? What's the same? The slope. So if they're parallel, that means they have the same slope. Okay? So the line that is the line that is tangent to this function at x equals 2 is going to have the same slope that I have going through these 2 points. Does that make sense to you? Okay, so then I have this, so to find the slope of tangent at x equals 2, I'm just going to use these 2 points to find the slope. That'll be 6 minus a negative 4 over 2 minus 0. So that's 10 over 2, which is 5. Okay. So I have the slope of the tangent line. That's great. I have f. Is my answer D? No, because it's not asking me for the slope of the tangent line. It's asking me for the value of b. So what could I do here so that I can find b? I have this, right? So this is the slope of the tangent line. Where do you get the slope of the tangent line from? The derivative. This is f prime of 5, right? We have that value, but have we found the derivative? No. So I can find the derivative, right? You take the derivative of this right here. So f prime of x is equal to 4x plus b. Okay. So I'm looking for b. right? What is the x value where b is concerned? It's 2. The line tangent to the graph at x equals 2. 5 is the slope of the tangent line. It's not the x value, okay? So I have this. What I want is f prime of 2 so I can get the y value, right? So f prime of 2 is going to be 8x plus b, right? What did I do? Yes. Well, and I just realized I wrote this wrong. This is not f prime of 5. I'm an idiot. No wonder y'all were confused. This is not f prime of 5. It's f prime of 2, because I'm an idiot. It's the slope when x equals 2, right? Because this is the x value, and the slope is going to be the same as this. It's f of 2. It's f prime of 2. I can't even say it. It's f prime of 2, not f prime of 5. Okay? It is the slope when x is 2, and that's what the derivative gives me. So when I have this, and yes, it is 8 plus b. Now that I have that these two are the same, I can say 8 plus b equals 5. So what does b equal? -3. Sorry. Got the wrong thing out there. Ask me a question, because I know I confused you on that. No, we're good on that one? Okay, so I'm going to give you the assignment. We're going to do the first one together, because although it's fairly simple, it's the first time you've seen it. So I'm not sure why it's on here, but I left it anyway. So it says to find the second derivative. Well, we know how to find the derivative, right? So let's find the derivative, f prime of x. Okay. Is that pretty easy to do? Yes. So we get -24x squared minus 10x plus 7. Yes? So not only is that the derivative, it's what's called the first derivative. The second derivative is when you take the derivative of the derivative. And it looks like this, f double prime. That's the second derivative. And we'll talk about what it means and what it gives us. So all I'm doing is taking the derivative of another polynomial, and I'm taking the derivative of this one. So this would give me -48x minus 10. I could take the third derivative. What would the third derivative be? -48. Okay, so you get the idea? Then we're going to stop there right now. Not that we're going to look at. Okay, there could be. You could keep going, but there's only so much it's going to give you. All right, so this is the only one it asks you for on that, and then the rest of these are going to follow along what we've had. This is just kind of a little preview. Okay, so I will get the keys put together in an organized fashion so it makes sense for you and it's easier for you. But stay up on your assignments. Ooh.